Problem 5.6. In this problem, we have steel spheres with a diameter of 12 millimeters, which are annealed by heating them to an initial temperature of 1150 Kelvin and then being slowly cooled to 400 Kelvin. And they are placed in an environment in which the temperature of the air is equal to 325 Kelvin. The properties of the air are provided, as well as the properties of the steel. We need to determine the time that is required for this cooling process. This problem is said to be transient, one-dimensional. We're going to neglect radiation. We are going to assume constant properties. The first step in the analysis is to evaluate the Biot number, which is defined as h, the critical length, divided by k. For an sphere, the critical length is equal to the radius divided by 3. Therefore, with the information given in this problem, Biot number is equal to 0.001, which is way below 1. Therefore, we could use the low capacity method. In order to find the time for cooling, we could use the equation 5.5 from your textbook. Therefore, the time is going to be equal to rho, volume, capacity, divided by h, the surface area, then the natural log of theta I divided by theta. For an sphere, we're going to use that the volume is equal to 4/3 pi r cubed. The surface area is equal to 4 pi r squared. The value of theta I is going to be equal to the initial temperature minus T infinity, and theta is going to be equal to T minus T infinity. The value for T initial is going to be 1150, and the final temperature is going to be 400. If we substitute all this part into the time equation, we're going to find that the time is simply equal to 1/3 rho r c natural log of Ti minus T infinity divided by T minus T infinity. Once again, the value of Ti is equal to 1150 Kelvin. The value of T that we want to reach is 400, and T infinity is equal to 325 Kelvin. If we plug all these values and the constants, we find that the time to reach that particular temperature is equal to 1122 seconds, or 0.3 hours. Please go back and be able to do all the calculations for this problem.